Today we're going to be talking about solutions for systems, and our essential question is how many types of solutions are there when you are solving systems? Okay, before we start everything with the new solutions, I want to go back and see and do a graphical organizer on systems of linear equations. So first let's start with the definition on this box right here, and we're going to put that it is two or more linear equations. So linear equation is just a line. So two lines with the same variable. Okay. Something to note, they usually have that left bracket to show that it's a system. So let's say sometimes a left bracket is used to show that it is a system. Okay. It doesn't always have it, but for the most part it does. So some examples of linear equations, we can look at two examples. Let's say we have x plus y equals 4 and y equals 3x minus 1. Right? Those are two equations. They're not both of them. Both of them don't have a y equals, but that doesn't matter. We can always move that x to the other side. But it has two equations, and they have the same variable, x and y. Another example would be one where they have that bracket, and they have like y equals 2 over 3x minus 1, and y equals 5x, right? They have that bracket, they have two equations, and the equations have the same variable, x and y. Okay, some non-examples, so examples are not systems of linear equations or systems of equations. Let's say you have this right here. The first one, let's say you have x plus 2y equals 4. Okay, that is an equation, but it only has one equation. And for it to be a system, you need two or more equations. Okay, so that's one non-example, so an example that is not a system of equations. Another example that's not an example would be this right here. Let's say we have 2x plus 2y equals 5, and one that says z, or no, let's use a different, because my 2's and z's look the same. T is equal to 5b plus 6, right? Those are not systems because they don't have the same variable. This one has an x and a y, and this one has a t and a b. They have to have the same variable. Let's put not the same variable. Okay, so let's go ahead and look at some of the different types of solutions. So we talked a lot about graphing these systems, and we only talked about this one right here where we have a graph and then our two lines, they intersect right here for our solution, right? Do they cross in this? Yes, they do. So I'm going to put yes. And then we looked at where do they cross? Right? And then we will look at whatever point that would be. So let's say it was like this point would be 1, 1, right? 1, 1, right? Where x is 1 and y is 1. Okay, and then that would be our solution. It has one solution. So I'm going to put right here, let me move this around. This one had one solution. Okay, but there's others like this one where if we have a graph and we have two lines that go, let's say they go like this. Let's say they're parallel, and parallel means that they never cross and they never touch. So if we ask the question, do they cross? On this one, we're going to say no, because they're never going to cross. No, because they're parallel. They are parallel. Okay. And if we say, where do they cross? Obviously, if they don't cross, they're not going to cross at all. So our solution here, because they don't cross, is going to be that there is no solution. Okay. Okay. That's another type of solution that you can have, where you graph them and then they just don't ever cross because they are just two lines that are parallel. They're never going to cross. They're never going to have a solution. So for right now, we have one solution and no solution. The other type would be that if we have a graph and then we have a line that goes this way, just like that. And then let's say we have another line that's right on top of it, right? And then you ask yourself the question, do they cross? Yeah, they cross. And where? Where do they cross? I'm going to put this in green. Yes. Where do they cross? So they're on top of each other, so they're crossing everywhere. Everywhere. They're on top of each other. They're the same line. Okay? So remember, our systems of equations, we have a solution wherever they cross and they touch. And if you have two lines that are on top of each other, they are crossing at the same, almost every single point, right? So every single point that they have is going to be a solution. So here we're going to say that they have infinitely many solutions. There's not just one solution, there's a lot of solutions, okay? Like all the points that it has as a line is going to be a solution. So those are our three types of solutions. We have one solution where they cross one time and that's your one solution. You have no solution where they don't cross at all, and so you just don't have a solution. You don't have an answer. It's kind of like an undefined answer. And then you have two lines are on top of each other and they cross everywhere, and you have infinitely many solutions.